My name is Robert Saul, and I am the founder of Aster BioScience. Aster is a gene synthesis company, and it is my third biotechnology startup company. Uh, I have a technical background. I started out as a physicist and a computer programmer. I ended up doing a PhD in biophysics, and I later did a postdoctoral fellowship at UC Berkeley in biochemistry. Berkeley was where I learned DNA chemistry, and that was the beginning of many of the projects that I did throughout my career. At Berkeley, I was in Berkeley in the mid-1980s, and our department was one of the first to have a DNA synthesizer. Applied Biosystems used our department as a beta test site, and I was able to study DNA synthesis technology, and I found that there was inefficiencies in it, and I decided I wanted to build my own DNA machine and start my own company to sell synthetic DNA. This was at a time before techniques like PCR were commonplace. But I was convinced that DNA was a fundamentally important commodity and that whoever could make it would rule the world. So I got together some funding. I had no money. I was a postdoc. I was living in a very small house in Berkeley. I ended up going and applying to 50 different credit card agencies, and I also did some blackjack playing to, I was able to win about $10,000 card counting, and I was able to raise $30,000, which I used to start my first company, which was Operon Technologies. I invented the platform. I got my working prototype working inside my Berkeley garage. I later moved that to a warehouse, and there I was able to do the actual chemistry. We started shipping our oligonucleotides to beta customers who were just academic friends of ours, and eventually some of those academic customers started referring us, and we were able to quickly take over the market. Operon became at one point the largest DNA supplier in the world, and when I left the company, we had driven sales from zero up to $25 million per year. Operon also did work in gene synthesis, and I wrote the software for our gene synthesis system and also designed the process. And Operon was able to build synthetic genes by linking together many oligonucleotides to make structures, DNA structures as large as 8,000 base pairs, which at the time was as big as anybody had ever made them commercially. Later on, the gene synthesis industry evolved. Today, genes can be made very inexpensively because the starting materials are much cheaper. However, there's kind of a limitation in how big these things can be made and sold routinely. Right now, there are no companies that sell synthetic genes larger than 10,000 base pairs, at least not routinely. They'll do it on a special order basis. And this is actually kind of a problem for the industry. There are emerging needs for much larger DNA structures for many evolving research areas, especially the co-expression of multi-protein complexes. And customers are forced to make these larger multi-gene structures themselves in-house at tremendous waste of time and effort. Aster's idea is to be able to make routinely very large DNA structures. So my current company, Aster, is planning on ultimately being able to offer on a routine basis synthetic DNA structures up to 200,000 base pairs. This is a revolutionary idea, and in some ways it's kind of an extension of my life experience. I started off making oligos up to about 100 bases, then I pushed the technology to make genes up to 8,000 base pairs, and now I'm interested in pushing that farther all the way up to 200,000 base pairs. I believe it's a revolutionary idea. I think that there are a lot of, and there's no competition for that business, and that there are many different applications that will be enabled and will become widespread as a result of what Aster is trying to do. The actual product we sell is going to be similar to what gene vendors produce already. We'll ship our product in a purified plasmid and in the customer's vector if they choose, and then the the customers will be free to do the molecular biology research that they want to do. Thank you.